Hi, my name is Avril Sauter and we're talking about CCNA Wireless. In this lesson, we're going to talk about configuration and operation of autonomous access points. There are four ways of connecting to an access point from a configuration perspective. And the first one is going with the console access. Now, autonomous mode access points, when they ship, do not have an IP address. So the first thing you need to do is to give it an IP address. And you can do that through one of two ways. Either you assign a static IP going through the console port and through the CLI, or you use a DHCP server on the network to automatically assign an IP address. Now on the right you can see an example of a serial cable. You'll notice that on one end is got a serial connector, the DB9. A lot of the newer PCs, tablet devices don't have a serial connector, and if you have that situation then you'll need to get a serial to USB adapter. You'll notice the other end of the cable is just an RJ45 connector, and that will plug in directly into the back of the access point. And if you look at the back of an access point, you will see a console port and an Ethernet port, and of course you need to be plugging this in to the console port. Then you'll want to go through a tool such as PuTTY to connect to it. On this slide here you can see the port settings that you need to set on your PC in order to connect to the access point. A lot of times people who are just starting out, and you guys are meant to have your CCNA, so you should already know this, but just in case, if you're connecting with a Windows 7 or a Windows-based PC, and you're not sure what your COM port setting is, then just go into your device manager, and underneath there you'll see ports, and then you'll be able to see the COM port that you're using. So our second method is we telnet in, often referred to as the virtual terminal access. Now this does require IP connectivity, and so if you look at the diagram over on the right here, you can see towards the bottom, when it does show IP interface brief, that there is a BVI interface defined and it has an IP address. And so the easiest way to do this is just to have your access point automatically find an IP address from a DHCP server. Then you can take a look on your DHCP server as to the IP address that's been assigned to it. Once you're on the network, then you would literally just type in telnet and the IP address of the access point, and then that would get you into the access point. Access points that ship to Cisco always come with a default username and password of Cisco, and so you can use those then to then get in to the exec privilege mode and then start configuring your access point. When you're in, you want to set different passwords, so usernames and passwords, and you can also set it up to come in through the secure shell interface, and that's highly recommended. As soon as you get in, one of the first things you want to do is to set that up. Once you've got an IP address, of course you can also now connect to the access point through a web browser, and you can bring up a web browser like Internet Explorer or Firefox, and you type http:// and then the IP address that's been assigned to the access point. That will then display a screen like you're seeing here to the right. Now, if you've defined secure shell on your access point previously, then you would need to come in through HTTPS because you'd be using encryption over that link. Now, if you're first setting up your access point and it's the very first time, I would encourage you to configure it through the web browser. And you'll see in the diagram over to the right, in the menu options, it says Express Setup and Express Security. And if you run through those, you can get your access point up and working very, very quickly. You can then go into the other submenus and configure the capabilities that you need that weren't defined in the Express setup mechanisms. What I personally like is if I am making a small change, like a maintenance change to the access point, then I prefer not to go through the web interface, because if I'm making a small tweak change to something that's already been deployed, sometimes it takes me a while to work my way around the browser interface to work out where the field is that I need to change, and I find it quicker and easier to go through the CLI interface by telnetting to the access point. So again, preferred method for initial configuration. If you're doing and you're very familiar with this interface, then do use it for maintenance. Again, personally, I prefer for maintenance to go in through the CLI. For small changes, the last thing I want to talk about when it comes to connecting to an access point is SNMP, the Simple Network Management Protocol. Now, this is a standard that's used in IP networks to actually manage devices that include access points, routers, switches, printers, PCs. So it's a protocol that's literally just will send information between a device like an access point and your network management tool that enables the network management tool to monitor and to manage that device. And so if you're going to connect your access points to a network management tool such as the Cisco wireless control system, then you need to configure it for SNMP. And you can do this either through the command line interface, through the web GUI we just looked at, or you can actually configure it in the Cisco wireless control system. Now, clearly, if you're going to be managing this device, you need it connected on the IP network, so it needs to be up with an IP address assigned to it. So one thing to be very clear on, you can take an autonomous access point and have it being managed by the Cisco wireless control system, but remember, an autonomous access point does not talk to the wireless LAN controller. It can talk to the wireless control system, and I find sometimes people get confused by that. So now what we want to do is we want to go through and talk about the Express setup screen and the Express security screen, so you understand the features and attributes that are configured through those ones, and then once you understand that, you can say, okay, is that good enough for my deployment, or do I need to go back in and configure some attributes that weren't included in the Express setup? So let's take a look at the Express setup first. And this will get your access point up and running. So the basic settings here, you can put in your host name, you can decide whether you want to assign a static IP address or use a DHCP server. Put a big warning on this slide. If you do assign a static IP address and then you connect that access point to the network, or if it was connected to the network and you're going in now and changing it to a static IP address, there is a risk that if you set that wrong, that you'll make it impossible to access that access point via the port on the network that you have it connected to. And the only way to fix that problem once you've applied those settings would be to go through the console port. So really be careful if you've decided to assign static IP addresses. In addition to the Express setup, there's also an Express security setup. And this is where you would set your SSID settings. You can indicate whether or not you want to have that SSID broadcasted within the beacon. You can enable a VLAN here, and then you can go through and set up some basic authentication settings. So you can indicate whether you want to have no security, whether you want to use EAP authentication or WPA. It also has the ability for you to say, okay, here's the radius server that I want to connect into, and you can key in the radius server secret that's required in order for you to communicate to that server. Now, a couple of snippets here for when you're deploying this. When you set up your first SSID, it will override the default SSID of the access point. And then you can go ahead and set up other SSIDs. And each of those SSIDs, you can choose a different security setting. Now, if you go ahead and set up multiple VLANs for those different SSIDs on your access point, it'll actually give you a little bit more flexibility on the security side. If you don't use VLANs, the security options are more limited. So for instance, if you choose an SSID, let's say with static web, and then you want to create another SSID, but you want that SSID to use WPA authentication, you cannot do that unless you've set up different VLANs, because they use different encryption settings. And so if you want to have multiple SSIDs with different security settings, do go ahead and set up the VLANs. Now, if you're setting up multiple VLANs, then you need to be able to connect to a trunk port on the switch. And so when you define that switch port, define it as a trunk and make sure you only put the VLANs that are supported by this access point. Bottom line is, when you go in and configure your access point, make sure exactly you know what VLANs, what settings you want to do. Even though it's Express setup, you still need to pre-plan it. So once you've assigned your SSIDs, your radios come up, but there are some times where you want to go in and actually change your radio settings. And you would do that by selecting the interface options at the access point's GUI. And there are several interfaces that you can go in and set. There's the Ethernet connections, where you're connecting to the actual wired network. There'll be the radio settings, and it's a different interface for the 2.4 gigahertz radio and the 5 gigahertz radio. So remember that if you're doing your settings, do not assume that it's for one of them it will apply to the second. You have to configure them individually. There's your BVI interface. And remember that from an access point's perspective, the BVI effectively represents the IP address of the access point, and so all the interfaces are in the bridge group that's represented by the BVI. You can also go in and configure your access point to support VLANs. Similar to what we saw earlier, you first enable the VLAN on the radio and the Ethernet port. You assign the SSIDs to the VLAN, and then you assign the authentication settings to the SSID. So very important to be aware of how to set up the VLANs and the SSIDs. Now, if you're setting up all your SSIDs to have the same security settings, and all the SSIDs are associated to a mobility network, then you can set up the Ethernet switch port that the access point is actually connected to. You can set it up as an access port. Now, an access port is normally assigned to the native VLAN. Similarly, if you just have a single SSID, you have a single VLAN, you can set up your switch as an access port. More typically, what you'll see though is the requirement to set up multiple SSIDs, and in which case you need to set it up as a trunk port. Whenever you have multiple VLANs, you must be using the encapsulation 802.1q tagging, and so you need to enable the .1q protocol on the trunk port. So now we've talked about the setting up of the different interfaces. Let's take a deeper look at the security settings. So the first thing you want to consider when you're deploying your autonomous mode access points is what authentication and encryption are you planning to use. And bear in mind, an autonomous access point can actually be used as a local authenticator, basically a standalone authentication device for your wireless LAN. Or you can configure your access points to use a radius server, which can be local or it can be remote. Now let's first talk about your authentication, authorization, and accounting. Authentication is where you're validating the identity of a user, and that quite often is simply with a username and password. Authorization has more to do with the rights or privilege levels of that user, and accounting is the logging of activities that that user does. So there are many different ways of authenticating and authorizing a user onto the network. So this requires careful consideration. Also, in addition to authenticating and authorizing the user on the network, you've got the issue of the privacy of data, and that's where encryption comes into play, where it literally scrambles your data in order to prevent somebody else eavesdropping onto it. And when you're thinking about encryption, then you're thinking about configuring a cipher suite. Now, not only do you need to think about the cipher suite that's actually going to do and apply an encryption algorithm to encrypt your data when it's sent and decrypt it once it's received, you also have to think about how your keys are distributed across the network. So on most wireless LANs in corporate environment are using the AES-CCNP protocol, which is based on the Advanced Encryption Standard, and this uses a symmetric cipher block that encrypts and decrypts your data. Some older deployments might be using WPA as opposed to WPA2, and you may see TKIP being used, and TKIP again is another suite of algorithms that can provide security and encryption to your wireless network. And ideally you should be looking at WPA2 both for your authentication and for your encryption. One of the other security things you should be thinking about is intrusion detection or intrusion prevention. The difference between intrusion detection and intrusion prevention is that intrusion detection attempts to look at certain patterns, certain things that are happening on the network, and then say, oh, this may be a potential incursion on the network. Intrusion prevention then takes that to the next step and says, given this is happening, I am now going to enforce this policy. And so intrusion detection finds the things that it thinks is potential for malicious occurrences, and intrusion prevention not only finds it but takes some action to resolve it. When you look at intrusion detection, what you're looking at is you need to have something that's sensing the network. So you might have access points deployed which are purely in the mode of censoring, and they're censoring 24/7, listening to the RF environment and seeing what might be a rogue access point or a potential attack on the wireless network. You can deploy your access points to operate in a sensor mode periodically. So occasionally they sniff the air, but it's not 24/7, and during the rest of the time it's operating as a normal access point. And you would do that if you wanted to save costs on your deployment. Also, you can look at normal network activity, and if you see a sudden change in activity, like, a phenomenal number of access requests that you've not had before, that might be an indication that you're having a denial of service attack. Then you can look at specific signatures. So signatures are known attacks, and they have an attack profile, and an intrusion detection system is normally regularly updated with those different types of signature attacks, and then it's just looking for them. And so an example of a signature attack would be if I received a lot of authentication requests from the same MAC ID. And then, of course, you want to be logging the possible attacks. And as always with these systems, you have a careful balance between you want to flag as much as you can because you don't want to expose anything on the network, but you don't want to flag so much that is so overwhelming to the administrator that they start ignoring it. So the drawbacks is those false positives where, hey, it really isn't an intrusion, it really is just a spike of activities. Also changes in the attack signature, you always have to be updating with new signatures as new attacks have been resolved and detected. Then you always want to update. It's no different than updating your spyware software on your computer at regular intervals. I always think the denial of service attacks are the worst possible attacks on the network. And the reason is because it literally makes the network unavailable. So the wireless network, your computer resources, are no longer available because it's been flooded with spurious traffic. And there are lots of examples of this. You know, some of the ones that I see in the wireless environment, the ones that I mentioned, is when you see an attack which is doing a lot of probe requests, authentication requests, access requests, and the more sophisticated ones, they can change the MAC address of the device, and so it looks like they're coming from different devices, and it's just a lot of activity at once. And as those requests are being sent over the air, is stopping anybody else getting access to the air. Now, there are ways of mitigating some of these attacks. A lot of them have to do with making sure your RF environment is clean. Management frame protection encrypts your management frames so that people can't eavesdrop on them and then easily duplicate frames that look like valid frames. And again, the best way is constantly to be listening to what's happening over the air, and if you see an attack, sometimes you just literally have to go out and go find it and make sure that radio, whatever's causing the problem to the network, is turned off. Well, let's now take a look at a demonstration at how I actually set up an autonomous access point. So let's connect to my access point. Now, prior to starting this demo, I have taken the physical access point. I held down the reset button for 20 to 30 seconds. It flashed blue lights and then it went red to tell me that it reset. I'd then gone in and typed in reload. So it's reloaded the factory default settings. And so now if I do show running config, you can see the default factory settings for this particular access point. And here you can see the interface, the BVI interface, has no IP address associated with it. So the first thing I want to do is to assign it an IP address. So to do that, I do config T, and then I go into the interface BVI 1. I then simply give it an address, and in this case I'm going to give it 192.168.70.101. And that's all I need to do to give the access point an IP address. What I can now do is I can access that access point via the IP address via a browser. So let me just save this config. And now let's go to my browser. So I've now connected my computer directly to the access point through the Ethernet cable, and I've brought out my Internet Explorer. And now I can type in the IP address that I assigned the access point. Key in the password. And you can see now that I've been able to get in to the access point web GUI. So I can select the Express setup, and then I can start to configure my access point. And you can see here that it's already shown the static IP address, and so I can give it a host name. I'm going to leave it with the static IP address for the moment. Here's where I can set up the SNMP. Coming down, you can see I can set up the role. I'm going to leave it as access point. And here I can define, do I want to set this radio to be optimized for throughput, which will turn off the lower data rates and therefore improve the average data rate that my users experience. And here's my range, which will support the lower data rates and maximize the coverage of my cell radius, or I can leave it with the default. This here is for my 802.11 2.4 gigahertz radio, and down here you can see I could do the same for my 5 gigahertz radio. The AeroNet extensions would be things like load balancing, message integrity check. If I had a network that had a lot of non-Cisco client devices, I may actually disable that feature because it can improve performance if I do that. So I can select here my SSID, so maybe I want to have this for employee. I can say yes, I want it broadcasted in the beacon, and here I can set up the VLAN, so maybe I want to set this up on VLAN 70. And here is my option if I want to set up a native VLAN. In this case I'm not going to do that. Come down. You can see the security options that I have. In this demo I'm just going to leave it as no security, but you have the opportunity here to set up EAP authentication or WPA. And then I hit apply. And if we scroll down a bit, you can see now that my SSID is now shown down here and is successfully been set up. I can then go back up here. So if I want to set up another SSID, I can do that. I key in here the word guest. We won't have this one broadcasted in the beacon, and here I'll set it up on VLAN 80. I'll leave it as no security. Click apply. OK. And now you can see at the bottom here I have two SSIDs set up with two different VLANs. I can now go here over to my network interfaces, and you can see here that my radios are down, so they're down by default, and so I want to enable them. So this is my 2.4 and this is my 5 gigahertz, and I'm going to enable the 2.4. I go into settings, And here is where I will enable the radio, so I'll select that. The role, of course, is as an access point. And here you can see if I want to turn off any of the data rates, I can do that here. Just going to leave that. I can change the transmit power here and also the power that the client can transmit at. Now when you're configuring your access points, do make sure you give it time to populate the settings. Like here it's got settings. If you don't, what's going to happen is that you'll start keying in the settings and then they will disappear. So we're going to enable the radio, which is a good idea. And here you can see I set it up as the default. So these are the data rates that have been enabled. You can see the power settings. I would always change the power settings, both in a lab environment. There's no reason to have really high power, but also you never really want to deploy at maximum power either, because you always want an ability to increase your power level, and you've also got to cater for your lowest level devices that are on the network. Here I can choose the channel that I want to operate on. Let's say I actually want to set it up for channel 6 maybe. I can define the channel width. This is an 802.11n, so I can go up to 40 megahertz if I want. And here are some of the other settings I can go and set up regarding my antennas and other attributes. So always remember to click apply. Now I want to go in and configure my 5 gigahertz radio. Click settings. And again, give it a while to populate. There we go. And then I can select enable to enable this radio, so it's going to be on. Again, the same settings that you saw in the 2.4 gigahertz band. Here, of course, I can have dynamic frequency selection in the 5 gigahertz band. But other than that, you're going to find it's exactly the same. Select apply. So you've now seen how I can go in, do a quick express setup, including the security settings, and then I can go on into the radio interface and enable my radios. I've come back here to my PuTTY interface where I still have my access point configured, and you can see that the settings have been merrily happily tuning away, and so now we can do a return on this. You can see that it now has its name, Autonomous, which is awesome. And I can do a show running config. You can now see here my SSID set up on my VLAN here, and here's my guest SSID set up on VLAN 80. So I'm now going to go ahead and connect with my laptop to the access point. And there you see that my laptop, my Acer laptop, has successfully connected to the access point coming in through the SSID employee. I have now set up a guest profile, because remember the guest is not set up in the to broadcast, so I had to set up a profile called guest to try and connect to guest. So I'm now going to connect to that, and there you go. I have now connected to the guest network. So I've confirmed that both of them are working. So we have now finished the demo. We have successfully set up my access point. We've given it an IP address. We've configured the basic settings, the security settings. I enabled my radios. I set up two SSIDs, one was broadcasted, one was hidden, and I was able to connect to both of them from my laptop. So in this lesson I want to talk about how to convert a lightweight access point into an autonomous mode access point. And you might say, well, why would I ever do that? Well, there are some situations that I've come across where this becomes quite important. Often a small business might be using equipment that they bought secondhand and they need to reconfigure it. I've seen this setting where people have bought the wrong access points and they bought a lightweight mode and they need to convert it to an autonomous mode for deployment. They simply bought the wrong product. So let's take a look at that in this lesson. Now you can convert your lightweight access point to autonomous mode simply by loading the Cisco iOS release that supports the autonomous mode. So that sounds pretty straightforward. And typically it ends with a JA in terms of the naming convention. Now the first thing you want to do is to make sure that your access point can actually be converted to autonomous mode. So for instance, the 3500 series only operates in a lightweight mode. Remember that if you're operating in autonomous mode, some of the advanced features like a clean air, etc., do not work. For that you need to be going through a wireless LAN controller in a lightweight mode. So go onto the Cisco website, find your access point and take a look whether it will operate in an autonomous mode. If it then does, then you need to download the image from the Cisco website down to a TFTP server. One of the things to watch for is where your TFTP server is located, because remember that if you're connected and you've currently got lightweight access points going through a wireless LAN controller and your TFTP server is accessible through the controller and you want to set this back to autonomous mode, then that's going to cause you a slight problem. Now one way to do it is to use your wireless LAN controller to convert your lightweight mode back to autonomous mode. And if you have the 1300 series access points, you have to do it this way. And what you do is you set up your TFTP server and you need to make sure that both the wireless LAN controller and the access point can ping that server from their current location. And then you simply go into the command interface on the wireless LAN controller and key in the command that's shown here on this slide, configure AP, and then you tell it that you want to downgrade, tell it where the file is, and the AP name that you want to send the configuration to. To verify that the image has actually been sent, you can take a look at the statistics in the log file. You should be then able to reboot the PC and it should then come up as an autonomous mode access point. Once the access point has rebooted, then you can go back in through the GUI or the CLI and reconfigure your access point as an autonomous mode access point. Another way of doing it is simply to transfer the file directly from your TFTP server. Now, one of the things to know is that if you're connecting your laptop directly to the server that I have running on my laptop where I have my TFTP, I do not need a crossover cable. The AP will automatically handle that for me. You configure your PC where you have your TFTP server running with one of these IP addresses in this range. You make sure you've got the right iOS image on your TFTP server with the right name onto it. You simply unplug the power on the access point. You press the mode button so that it resets to its factory defaults, and you release after about 20 to 30 seconds the mode button. If you look at your TFTP server, then you're going to see the transfer actually starting between the access point and your PC. You wait for the upload to finish and then you reboot your access point. I hope you've enjoyed this lesson.